Hello and welcome. In this video we are going to talk about Euler equation. Euler equation. So we are going to talk about only second order Euler equation, but it's very easy and very similar to see higher order Euler equations. So Euler equation is of the form ax square y double prime plus bx y prime plus cy equal to 0. So basically, if you are talking about second derivative, x square is multiplied with it. So similarly, if you are talking about nth order Euler equation, it will look something like this. an xn, the nth derivative, plus an minus 1 xn minus the power n minus 1, the n minus 1th derivative, so on. In the last we have a1 x y prime plus a naught y equal to 0. These a, b, c and these all ai's are constant. So this is the form of Euler equation, and how we solve this is very simple. We are going to use a substitution, and the substitution is v equal to ln x all the time. V equal to ln x. And what this substitution will do is this substitution will reduce it to a second order, if you are talking about second order Euler equation, to second order homogeneous equation with constant coefficients, which we already know how to solve. Okay, so how this substitution work is explained in your notes, so please go ahead and see your notes how this substitution work. What I'm going to do is I'm going to write down directly the characteristic equation. So if you use this substitution, your characteristic equation will be a times r minus 1 plus br plus c equal to 0. The point to remember over here is when you are writing this characteristic equation, your independent variable is v. So suppose if you have two roots, -1 and 2, for the characteristic equation, your solution will be y equal to c1 e power -v plus c2 e power 2v, and then you will substitute your v equal to ln x back. Similarly, if you are talking about nth order equation, your characteristic equation is given by an r times r minus 1 r minus n minus 1. So basically we have these n terms for nth derivative, and the last term is r minus n minus 1. Similarly you can write for others. I'm just writing last two terms, which are a1r plus a naught equal to 0. Let's see example how easy these Euler equations are. So our first example is x square y double prime minus 3x y prime plus 3 y equal to 0. This example, let's work on this example. So if we use the substitution, so we substitute v equal to ln x. If we use this substitution, then our characteristic equation is given by x square r times r minus 1 minus 3r plus 3 equal to 0. Now we want to find the roots of this equation. Oh, not x square, just the coefficient. The coefficient is 1, so just r times r minus 1. So we have r square minus r minus 3r plus 3 equal to 0, which means r square minus 4r plus 3 equal to 0. You can factorize this or you can use the quadratic formula. I am going to factorize this because factorizing this is simple. R minus 3 times R minus 1 is equal to 0. So either R is equal to 1 or R is equal to 3. Remember, V is our independent variable. So the solution Y is equal to C1 e power V plus C2 e power 3V. This is the case of real distinct roots. But our original equation was in terms of x, so we will substitute V equal to ln x back. So we have C1 e power ln x plus C2 e power 3 ln x. And we are going to use the property of natural log, which is b times ln of a is equal to ln of a power b. This b comes in the power. So this basically is equal to C1 x, because exponential and natural log are inverse of each other, plus C2 x cube. And this is our answer. So basically, if you know how to solve equations with constant coefficient, then working with Euler equations is very simple. Let's see one more example. And the next example is to solve t square y double prime plus 7t y prime plus 10y equal to 0. So in place of x, this time our independent variable is t. So we will substitute v equal to ln t, and then our characteristic equation will be r times r minus 1 plus 7r plus 10 equal to 0. So this is equivalent to saying r square minus r plus 7r plus 10 equal to 0. R square plus 6r plus 10 equal to 0. So we want to find out the roots of this equation. Let's use the quadratic formula. So using quadratic formula, r is equal to minus b plus minus square root of b square minus 4ac divided by 2a. Right? So we got negative 6 plus minus square root of 40 minus 36 is 4. So we have negative 4 divided by 2, which gives us negative 3 plus minus 2i. So y is equal to, remember our independent variable is v. So y is equal to e power negative 3v cosine c1 cosine 2v plus c2 sine 2v. Now we will replace our v by ln t. So e power negative 3 ln t c1 cosine 2 times ln t plus c2 sine 2 times ln t. We use the same property again, and the coefficient goes in the power. So we can say this is same as writing t power negative 3 c1 cosine ln t square plus c2 sine ln t square. Right? Oh wait, so when we are finding the roots, we have negative 2i divided by 2 also. So this is actually I made a mistake over here, so this should be I. So we don't have this 2. So c1 cosine v times c2 sine v. So we don't have this 2. So this is our answer. And we'll stop here today. And please practice more and more problems. And I'll meet you in the next video. Bye bye. Take care.